Hello guys, my name is Matthew Pyatt and I do engine machining. I'm also a full-time pastor, so I've turned my engine shop into a hobby shop. I do a little bit of machine work for friends and such, but mainly I'm turning my shop into a place that I can just relax. I can piddle with my cars, I can build engines for myself. I'm going to do a lot of testing, a lot of R&D work in here, things that maybe people have never tried before. Extensive modifications. We're going to see what happens. You know, how much can we mill cylinder heads and they still operate fine? How much can we deck a block? Can we run factory pistons and cut the block enough to raise the compression up and still be fine and reliable for a budget build? What can we do? I've got a few different builds lined up. I've got a BGE Hellcat block over here we're going to be building up. That's going to be a twin turbo build, probably, maybe a single turbo, but I'd like to go twin on that. I have a big block Mopar 400 block. It's a short deck big block. We're going to do probably a 451 stroker with it, and we're going to do a budget build on it. I've got some iron heads. We're going to do port work on it. I've got a tunnel ram we're going to run on it, and probably EFI, and then we'll either run maybe nitrous or a turbo on that. Today I'm doing Harley heads. This is a friend of mine. They have a Harley shop. We do their cylinders and their head work for them. And I've already done the cylinder heads. I did not film them. I'm going to be filming some work with them soon, but today I'm just going to be boring the cylinders and show you kind of what goes into that. But basically, you know, I'm just wanting to do this channel for fun. You know, maybe y'all can learn something. I can do most machine work, all your cylinder head work, block work. There's a few operations that I can't do in-house and that I have to send out. But most of the stuff I can do here in-house. But like I said, I just want to do this, have fun. Hopefully y'all learn something, build the community up. And let's just see what we can do on a budget. Let's see what we can do in a hobby shop where we're not having to spend thousands and thousands of dollars, because I don't have that. But, you know, I make a little bit enough to play with, and I'd like to share that with you. But most of all, I want to be able to tell you about Jesus. I'm not going to preach to you, but here and there, I just like to talk to you about it, you know, introduce you to him. You know, Jesus, he came to save us all, and he's blessed me immensely. He's allowed me to be able to do this. He's taken me in places I've never thought I would go, and he's brought me through a lot of heartache and a lot of issues in my life that he's helped me overcome. But, you know, this is part of my life too, machine shop work, and I just want to share that with you. But today we're going to be doing the Harley cylinders. I'm going to turn you around over here, and we're going to show you how we set up our measuring equipment. We got a dial bore gauge here, and we have to measure the piston. I'm going to go get the piston real quick, and I'll bring you over here. My normal place of measurement, it's really messed up with clutter. Right now the whole shop's cluttery. I've been really busy, but I'm going to bring it over here. I'm going to show you how you set up the mics. We're going with a forged Molly piston. Went from a cast, we're going 10 thousandths over. But like most things in this industry, things are not always what they're supposed to be. It's supposed to be a standard 4-inch bore, and was going 410 over. And I do not like boring or honing cylinders without having the piston in hand. Usually I can, if I know the engine, I might go ahead and bore it, because I leave 3.5 to 5 thousandths to hone out. And it gives me a little bit of room to tolerance to adjust with the hone. But with these, we're finding out that I couldn't have done that. They're not the right size. We're going to make them work, because I can make it to whatever I need it, but they are not 10 over pistons. What we do is we take a micrometer as such, and we measure on the measuring points, which is this is right below the chamfer on the skirt. And we set our mic, which I've already previously done to this. We set it to fit. Put it in my little mic holding device. It's basically what all I use this little device for. It's really handy. Dial bore gauge does not actually measure anything. It's a comparator gauge, so it only compares. So we have to set this mic to the size we want, and then this thing just has a little thimble in there, moves up and down. It's just a gauge. So what we have to do is we have to set it to the size we want it, which this one is set perfectly. Make sure. I thought it was. Yeah. And we turn this dial here to adjust it and just set it where this zeroes out on here, and which this will be the exact same size of the piston. Now, obviously, we can't hone it to that size. It wouldn't have any clearance. It'd be a zero fit. So we have to actually add clearance. But I like to do this especially on pistons that are not the right size. And I can set the clearance. And on these pistons, on this bore size, I set them at about 3.5 thousandths clearance. I'll probably go to 3.5 on these. On the piston to wall clearance to get adequate room for expansion of the oil. But like I said, these were supposed to be 10 over. These measure out at 1.9 2/10. So if I would have honed those cylinders to the 10 over size like they were supposed to be, that would have only left 2/10? Yeah, 2/10. That would only left 8/10 clearance. These pistons need 8/10 is less than a thou. It's 2/10 less than a thou. These pistons need 3 to 3.5 thou clearance. This would have seized up immediately. So if you'd have bought a set of 10 over cylinders that offline, and then you bought your 10 over pistons and threw it together, and you wouldn't have really known what you were doing to measure, it would have locked up and ruined all your money and all your hard work. But I'm going to actually, these will end up being about 12 over is what it comes out to be. But anyways, it's no problem here. I can hone it to size and everything. But one thing you have to do, always measure everything in an engine. Do not take it for granted. Nothing. It's always wrong, almost always. It's wrong more than it is right. And I say that from experience. I've been doing this for quite a while, and I measure everything. I never can buy a set of bearings and put it in the engine and it'd be right. I always have to usually buy 2 to 3 sets. That'll be a standard X, which is extra clearance. It's 1,000th extra clearance. And then a 1,000th undersize, which is 1,000th undersize. And usually I'll have to just use a half shell, which will give me a half thou tight or a half thou loose with a standard bearing, which will take up, I can move the clearances around, but I hardly ever can build an engine and only accept one set of bearings. It's just not the real world and aftermarket things. There's too many tolerances. And I mean, will it run? Maybe. Will it last? Probably not. And that's why you need to set it right. You have to measure. Spend the time either to buy the proper tools to measure or pay someone to do it. And the bad thing about paying someone to do it anymore, you can't find trustworthy people. I hate to say it, but this industry is full of people that just tries to make a quick buck. And they just say, well, the customer don't know any different. And they just give you garbage. You'd be surprised at the horrible quality work that I've seen come in from other shops that I've had to fix. It's mainstream and it's unfortunate. And it gives us a bad name. And they're just trying to make money and get it out the door. But the best thing to do is if you're going to assemble the engine yourself, you need to have the proper equipment to do it. You cannot trust what the shop told you. They make mistakes. Even if they're an honest shop, they can make mistakes. And if you're not paying them $100 to $150 an hour minimum to check the bearing clearances for you, to measure your crank out, don't expect it to actually happen. Because if they only charge you $20 to measure your clearances and say these are the bearings for it, they didn't actually measure it. There's no way they took that time and only charged you $20. It's going to be about a $150 charge to measure out your bearings on your crank minimum, just for the mains. It would take more than that for the rods because you got to measure every rod. You got to torque them up and compare every journal on the crank to every rod. But anyways, I'm getting on a rant here. We're not doing cranks today. We're doing pistons. So I'm going to take this cylinder. This is the one we're going to bore out. And this is a standard bore. And this is what I have set for the new piston. Obviously, it will not work. Right now, we're going to be removing. This is showing about 8 3/7 tight versus this piston. But where we're going to move it, we're going to actually leave about 4 thousandths to hone out in the hone after we bore it. This is our cutter for the boring bar. I'm hoping you can see this. Like I said, I'm new to filming here. Screw adjust it. It's a carbide cutter. It can be lapped in, sharpened, whatever. You can buy insert tooling for this, but these work really good and they last a long time. Here's the micrometer. They have the numbers on it. We set our tool with that. Make sure we're zoomed in here. We set this in here. Screw this in just like a regular mic. And this one is set right at 4 we leave about 4 thousandths on the piston. So we take this cutter and we put it in our boring bar in a minute. But we have to actually clean the cylinder. There'll be a little bit of carbon on there. First time, I usually just take a brush. And I don't really have to worry about scratching the deck surface up with this because we resurface all the cylinders we do. I don't send them back out after boring them with a factory surface finish because first of all, it's usually not correct for the MLS gasket they're going to use on these performance builds. And second, they're usually almost always warped. These air cylinders, they move around. Now, once they went through a heat cycle, once they've been ran from factory, they have miles on them, they'll settle, the metal will move around, then it'll find its home spot, then it's what they call a seasoned. Then once you surface it, as long as you don't overheat it or abuse it, it should pretty much stay flat after that, unless you have issues with your engine. But the metal does, when it's new, it does move around after it goes through heat cycles. And I'll take this little diamond sharpener, Harbor Freight, that's all you need. And just make sure there's no burrs or anything that'll cause it to be crooked in the fixture here. It's nothing really special. And I'll take a honing stone. This is the final. Make sure everything's good. I can tell you right now, this thing is warped. It's only touching on the edges. Next, pull this little case sealing ring off here. Next, we'll set the cylinder up in here. It's got parallels here that move side to side, adjust. I like to catch it on this surface here. It brings it up off of the cylinder. You don't want to be setting on the spigot part. You need air because the cutter doesn't cut flush, so it needs a little bit of room to come past it or it won't be able to bore the whole cylinder. Okay, then we'll slide these. These are machine parallels here. They're precisely ground, square. We set these up for that cylinder to come up against. And if for any reason y'all cannot see good in the video, just let me know and I'll try to fix the issues. Like I said, I'm an amateur at photography. I really don't know what I'm doing when I'm taking film. So I'm going to try to figure it out and y'all can help me figure that out as I go along. And I will try to make the quality better and better as we go so y'all can have the best quality possible. We just snug this up. Now it's tight, can't move. Then we take the boring bar, we loosen the boring bar up. There's a clamp back here. It's got a foot on it that clamps it down when we tighten the bolt to the table. We have to loosen that up where it can move now. And it slides around pretty easily. It's got oil on it, on the plate, and so it moves around pretty good. And just took the clamp off. But what we do is, these are centering fingers. When I screw this out, these expand. There's 4 of them. And that expands in the cylinder. And since this is free, it floats it towards the center. And it centers off the existing cylinder. We need them fully retract because these are there's different shoes. And this one, they're just barely fit in this 4-inch cylinder. They're made for bigger cylinders, but they will work on the 4-inch. As long as they go in, it works. But they're almost at their minimum size they can be used on. So I have to have it really centered up. But I like to blow them centering fingers off because if there's any metal shavings in between it, it'll be off center. And usually I try to center off about in the middle. Because you got to remember, you have wear in the cylinder. It wears more at the top. And it don't wear perfectly centered. There's a little bit of thrust side. So it's going to move it around. And that's why you have to have enough material taken out to freshen up the cylinder. Because it can leave shadows if you don't. So Usually move it around, tighten, make sure it's centered good. This has got a tensioner spring that holds tension on there, so you don't have to actually crank it down. It's pressure by spring. And then once that's centered, you tighten the clamp foot back up. There's different type of boring bars. There's boring bars like this, different brands, different types. And then there's boring mills, where it's just it's a big milling machine. And they're really good for different things, depends on what you're doing. But for stuff like this, you cannot beat the setup for these kind of cylinders. The other type has too much setup. You have to actually dial it in and zero it on the machine because you got the adjustable tables, kind of like a Bridgeport does. But there's a lot of time. This centers on itself, so you don't have to all that time. So it's made a lot quicker. And you release the pressure on the fingers. You retract your centering fingers. Then you retract your bar. You take your cutter. Once you verified it's set right, put it in the slot. Get it going square. There we go. And it locks in. You can tighten up a retention screw here, but it's actually spring loaded. You don't have to. I've got a tension set on it where I can just throw it in there. Now, if I was going to take like a big heavy cut, like taking the removed metal for a sleeve, I was taking a lot of material out, I would actually tighten that up just to keep it from maybe chattering. But on normal cuts, it won't chatter. It cuts perfectly good. This boring bar cuts extremely well. And these cylinders are actually hardened. They're ductile irons cylinders in these. Some of them are, not all of them, but they're a little tougher. Some of them are steel sleeves. Some of them are cast sleeves. Depends on what you're doing here. I was hoping I had a light. But anyways, what I do is I bring it down close, flip the switch on, and then this little thing puts it in gear. You hold it in until it takes off. And then the auto feeds in. I'm gonna go grab a light. I like to always check it because when you have wear in your board, like I said, sometimes it can be shifted over a little bit, the wear from the thrust. And since we're only taking 10 thousandths out, actually going 10 over, 12 over in this instance, it's actually only taking 5 to 6 thousandths off each side. That's not very much. And sometimes they won't clean up on that. They'll leave a little dark shadow where it didn't even touch from the wear, and you have to go bigger. So these are cleaning up just fine. They're borderline. You can barely see just a little bit of a darkening on that one side, where it's just barely touching with the cutter. But the thing is, I've got 4 more thousandths to hone. It'll clean up perfectly fine. But it is on the border of going 10 over. They about needed to go 20 over to get my light to work. But once the centering fingers get into the bore, try not to spray this hard and blow your ears out. You'll kind of snug this up and it'll slide down the cylinder. And that stabilizes the bar, because the longer the stick out, once it gets down further, the support stops here. So the longer it goes out, the more deflection it can have. On this, it don't really have any, but when you're boring long sleeves and stuff, it can. And what those do is, they just help keep it stable. It just supports it. You just put a light tension on it. All it needs. Just a little bit, which you can cut these without it. No big deal. But let me know in the comments what kind of things you want to see. What machining operations would you like to know how to do? I know most of y'all will never do this. Some of you might. Some of you might learn something and be able to get into this trade. But what do you want to see? Do you want to see, machining cylinders? Do you want to see surfacing heads or surfacing blocks? Toning? What do you want to see? Valve jobs? The majority of the stuff I just have to film of what I'm doing at the time, but most things have all those procedures on it, and I'll try to do some builds. I have a small block Mopar stroker I'm putting together right now. It's a 408 stroker, built from a 360 Magnum block, and it's got a lot of good parts in it. It's going to be a really good build. I've got everything ready. It's going to have trick flow heads on it, roller cam, it'll have a single plane intake on it. I might start with a dual plane and dyno it and see the difference between the single plane and dual plane on the dyno. But that one's coming up very soon, and it's a pretty nice build. It has good steel crank, scat rods, forged moly pistons. It's got really high-tech total steel gapless gas-coated rings, really tiny 1mm rings, K1 crank. We're running coated bearings on the mains rod and cam. We're running fuse engines, shaft rockers. I did have a clutch out in my pocket. Of course, I have to kind of babysit this, because it'll crash. You have to turn it off or it hits the bottom, obviously. It's almost done. You'll hear a sound change, obviously, when it stops cutting. And it's bored out. Now, this was the second cylinder. The first cylinder, I usually do in 2 passes. I do a light cut to make sure the tool's set where I want it, and then I'll adjust accordingly with the measure, and I'll move it up a couple more thousandths to the actual final size I want it when I'm boring. And I've done that on the first cylinder. So this cylinder, I just had to take 1 cut. So it was a little bit quicker. The next, you just release your tension on the guide fingers, retract them all the way. Then I'll release the clamp. You want to back the knife away from the cylinder. So release it. The knife is facing me. I slide it back a little bit, because if you drag that knife up the cylinder, it can leave a big gouge all the way up, and if you don't have much to hone out, you might not get it out, and you would have to actually rebore that cylinder again. I've seen machine shops accidentally do that. I know they don't do it on purpose, but they're not paying attention, not taking their time, and they'll gouge a cylinder, and the customer will have a gouge line all the way up their freshly hung cylinder. Anyways, slide that out. See that little dark line? That's what they call shadowing. That's just barely where it didn't completely clean up. Boring it. But like I said, I've got 4 more thousandths. That'll clean up perfectly fine on the hone and be a non-issue. But this one barely cleaned up on a 10 thousandths over. Actually, it's a 12 thousandths over because the piston size is wrong. So I got a little bit of dirt in there for my fingers. But anyways, it's good to go. So we'll take it over here and we'll measure it. We got about 1,007/10 tighter than the piston. And now the piston, that mic was set at 0. So we need 3.5 thousandths over the 0 bigger. So right now we have about 5 thousandths to hone. So it's actually a little bit more than I usually leave, but that's okay. You can always take more out. Can't put it back in. Well, I guess you can. I can put a sleeve in it, but I try not to do that. Although it's happened. My dad, he passed away last year in July, and he was my best friend. I lost a good man, a good Christian, godly man. He was the most patient man I ever knew. He would never bite back at you. He didn't fight with you. He didn't argue with you. He was very humble, and I miss him very much. But he was my right-hand man in here. I paid him to help me, and he knew nothing about this stuff. He knew about engines. He was an engine guy, but he didn't know about machining, and I taught him how to do things, and he would bore blocks, and he would hone. That's mainly what he did. I done the cylinder head work, but he messed up a couple cylinders, and we had to put sleeves in it. It's just part of it. And he bored one a little too big one time and had to put a sleeve. But you know, it happens. Mistakes happen in this industry. The problem is in this industry, mistakes happen, and then the shops won't talk about it. They won't tell the customer they made a mistake, and they'll just send it out the door hoping all goes well. The thing is, that's horrible. I know we've all had mistakes and they've all went out the door. That's happened. I've had that happen. I try not to let that happen, but sometimes we don't know we made a mistake or whatever it may be. Or sometimes we think, well, it's not really that big of a deal, and we but we should always tell them. We should be as honest as possible, because we're human. The customer's human. They understand we make mistakes. It's how we deal with our mistakes. Are we going to try to cover it up, or are we going to fix it for them? We have to own it sometimes. I've had to spend money out of my pocket because I've made mistakes before. That's just how it is. But I'd rather fix it and have a good reputation, have the customer say, the man stands behind his work. Although I don't do customer work anymore, except for a few friends as a hobby. But, we have to be honest. And that's the problem in this business. People are not honest. But anyways, back to it. These are bored, and now we're going to have to hone them. And I'm going to do a video on how we hone these in the hone over there, the hone cabinet. But I'm going to pause the video right now. If I don't come back, if this is the end of the video, I hope you enjoyed it. Please like and subscribe. Allow this to be something that it's worth doing. If I'm not getting likes, I'm not getting subscribes, if I'm not getting feedback on the comments, if we're not having good, profitable conversations in the comments, then I'm not going to waste my time doing this. I want to do this to help people. I want to do this to have like-minded people in conversation so we can talk about things. I can learn from you too. It's not all about me teaching you things. You can teach me things. You might know something about it that I don't know, and I want to learn from you too. But if I'm not getting any feedback, if I'm not getting likes and subscribes, then I'm not going to continue doing it. But I'm going to try to make a channel out of this. And I just think it's a subject it's the last 5 years it's came on YouTube, and a lot of shops are starting to do it. But some shops, they just don't go into the details on certain things. And I'd like to help you. Just let me know what you want to see, and I will try to do it. I try to take time out of my day to do it. But if I don't know what you're going to want to see, then I'm just going to do what I think you want to see. And that's how it's going to be. But please be very professional in the comments. Don't be nasty. If you don't agree with me, that's okay. That's fine. We might not agree. That's totally fine. But let's not use foul language. Let's not bash people. Let's be good people to each other. Let's just be kind to each other. This world is bad enough. People have so much hate in their heart. I love the Lord. I love Jesus. I'm not going to force Jesus on you. I really think you should accept him in your life and allow him to change you, because he is the one true God, and he loves you, and he died for you. God sent his only son, God in flesh, incarnate, to die on the cross, and he rose from the dead. There is proof, historical proof, undeniable proof. He rose from the dead. He was seen by hundreds at one time. There is more proof about the life and death and resurrection of Jesus than any other thing in history. Anything. It's undeniable. But anyways, I'm not going to push him on you. But even if you don't believe, just be kind to one another. Respect one another's views. Be a good human and a good citizen. But anyways, if I don't see you back again, I thank you for watching. Like and subscribe. And I will actually, if I get up to 10,000 subscribers, I'm going to do a giveaway. I've got things that I can give away. I'm already planning on it. And every 10 up to 50, I'll do a giveaway. At 50, I'll do a big giveaway. At 100 subscribers, I'll give a very big giveaway. And after that, we'll go from there and see. But it's no purchase necessary. Just give me some subscribes. Give me some likes, and we'll go from there. And let me know what you want to see. Thank you. And like I said, once again, my name is Matthew Pyatt, and I'm just a God-fearing man who loves to do engine machine work, and this is my hobby shop. Appreciate you.